The era of 70-ton armored behemoths fighting traditional attrition wars is over. The KNDS EMBT, a revolutionary collaborative combat system co-developed by France and Germany, has officially initiated its latest live fire on the move tactical trials, shaking the foundations of Eastern European defense paradigms. During real-world testing at the Burgess Proving Grounds, the platform unleashed its massive ASCALON 140mm main gun, a weapon system yielding an unprecedented 13 megajoules of kinetic muzzle energy. This technological reality places traditional armor in a highly vulnerable and defenseless state, shattering the long-standing tactical doctrine of mass production over premium quality. For over a decade, Russian armor planners relied on the T90M Proryv, a combat vehicle costing approximately $4,500,000 United States dollars, designed to overwhelm adversaries through sheer volume. However, leading global defense analysts argue that on paper, their only tactical salvation against this new European beast would be a complete and highly expensive redesign of their entire frontline fleet. The stakes have never been higher for regional deterrence, as the older standard 125mm calibers find themselves completely exposed against next-generation active protection systems. This leaves military strategists with a critical dilemma. Can a $15 million artificial intelligence-driven fortress completely neutralize a numerically superior force? Or will the harsh economic realities of industrial warfare render such advanced machines practically useless in a prolonged conflict? Before we go on, do you believe that advanced artificial intelligence can truly replace raw numbers on the modern battlefield? And tell me where you are watching from. If you want to stay ahead of the curve on global defense shifts, make sure to hit that subscribe button right now. To understand the core of this military friction, one must examine the critical physical limitations dictating modern armor design. For decades, the frontline strategy of the Russian Federation has relied on the 125mm 2A46M5 smoothbore gun utilized on the T90M. This mechanical architecture utilizes a carousel automatic loader placed directly beneath the turret floor. While this saves space, leading global defense analysts argue that on paper, this structural choice creates a severe kinetic bottleneck. The carousel mechanics restrict the maximum length of armor-piercing fin-stabilized discarding sabot projectiles to approximately 740mm. Consequently, Russian metallurgical engineers have reached a physical threshold where increasing muzzle velocity further risks catastrophic barrel pressure failure, leaving their current munitions struggling to penetrate next-generation Western composite armors at extended combat ranges. Concurrently, European defense planners have faced their own severe industrial vulnerabilities. The ambitious fifth-generation main ground combat system, originally intended to replace the German Leopard 2 and French Leclerc, has faced severe industrial delays. Intellectual property disputes and market share disagreements between Rheinmetall and Nexter pushed the projected deployment date from 2035 out toward 2045. This 10-year gap appeared at the worst possible time, as Western strategic reserves of older Leopard 2A4 and Leopard 2A6 variants faced rapid depletion through intense attritional warfare. Europe could not afford to remain defenseless for 2 decades while awaiting a clean sheet design. This urgent tactical deficit forced a radical engineering compromise, leading KNDS to bridge the gap by mating a highly advanced French digital turret with the battle-proven German Leopard 2 chassis. This temporary technological marriage was designed specifically to bypass the political gridlock and counter the evolving armor capabilities emerging from the Uralvagonzavod production facilities. The KNDS EMBT counters these engineering bottlenecks through the deployment of the uncrewed ASCALON demonstrator turret 140. This advanced configuration integrates the auto-loaded and scalable outperforming gun, a 48 caliber smoothbore system engineered by Nexter. This weapon generates a massive pressure spike inside the chamber, propelling specialized armor-piercing fin-stabilized discarding sabot penetrators with an unprecedented 13 megajoules of muzzle energy. On paper, this allows the platform to achieve complete kinetic overmatch against heavy armor configurations at distances exceeding 2,000 meters, effectively rendering existing Russian reactive protection systems like Relikt and Malachit highly vulnerable. Furthermore, the modular design allows field mechanics to swap the entire barrel from 140 millimeters down to 120 millimeters in less than 1 hour, providing tactical flexibility unknown in monolithic Soviet-style configurations. However, the true tactical leap lies within the implementation of artificial intelligence. The platform integrates the internally developed selection acquisition fire control engagement architecture, known as SAFE. This system acts as an autonomous digital combat assistant, utilizing high-speed computer vision and sensor fusion to scan the environment via 6 integrated anti-drone radars and 4 laser warning sensors. The software automatically detects, identifies, and prioritizes 5 separate battlefield threats simultaneously, queuing the primary gun or secondary armaments based on urgency. To address the omnipresent threat of loitering munitions, the turret mounts a dedicated ARX 30-30mm remote weapon station capable of firing programmable airburst ammunition to detonate directly above incoming drone swarms. Leading global defense analysts argue that on paper, this multi-layered digital shield solves the critical top attack vulnerability that has devastated traditional armored fleets. In the coming 12 months, as live fire on the move validation concludes, this paradigm shift is projected to force regional competitors into expensive, reactive defensive modernizations. The emergence of the KNDS EMBT deepens a fundamental divergence between 2 core military philosophies. On one side stands the industrial pragmatism of the Russian Federation, which relies on cost-efficient armored platforms manufactured at massive scale within the Uralvagonzavod facilities. This doctrine accepts standard technical capabilities, but maximizes quantity, aiming to overwhelm opponents through relentless attrition. On the other side stands the European model, embodied by the joint engineering teams of France and Germany. This strategy funnels millions of dollars into a single, high-technology asset, transforming an armored vehicle into an artificial intelligence-driven fortress that seeks to dominate the theater from distances where the adversary cannot retaliate. This technological push leaves defense planners with a profound strategic lesson. True protection on the modern battlefield is no longer measured solely by the thickness of steel plates, but by the processing speed of integrated computer algorithms and the ability to control local airspace. However, the $15 million United States price tag of this vehicle introduces severe economic trade-offs, especially as military logistics lines become burdened by specialized ammunition calibers and ultra-complex maintenance procedures. If a large-scale war of attrition occurs, the critical question remains whether a boutique fleet of highly advanced combat systems can withstand a continuous, high-volume industrial onslaught. The ultimate test of the KNDS EMBT will not take place on proving grounds, but against the harsh realities of supply chain endurance and industrial manufacturing limits. In a hypothetical frontline engagement, do you believe 10 mass-produced T90M platforms using swarm tactics could successfully overwhelm a single $15 million artificial intelligence-driven KNDS EMBT, or has Western technology rendered numerical superiority completely obsolete? Let us know your thoughts in the comments section below, and if you enjoyed this detailed strategic analysis, please like the video and subscribe to the channel for more technical defense breakdowns.